Hello everybody. Today we will start a new topic which is straight lines. So let's start with some basics first. Let's say this is a most of you will know this thing, but I will just start from the very basic. So this is an coordinate axis with this origin, okay? And let's say this is a straight line, right? With one point as x comma x1 comma y1 and another point x2 comma y2. So what will be the distance between these 2 points? So let's say we need to find this distance d, right? So what will be the distance here? So, let me do it from the basic here. So this one is x1, here it is y1. Similarly, for this point, this is x2, and this ordinate here is y2. So one thing, this x, it's called abscissa, x coordinate, and the y coordinate, it's called ordinate. Okay. So what is this distance? So for the distance from this point x1 y1 x2 y2, this distance will be, you see, if this is x2, if this is x1, then this will be x2 minus x1, right? Pretty simple, right? Straight. If this is x2, this is x1, this is x2 minus x1. Similarly, this is y2, and if this is y1, then what will be this distance? This distance. From here to here it's y2, from here to here it's y1. So this distance will be y2 minus y1. These are pretty simple stuffs. Many of you have covered in class 10 itself, so I'm going a little bit fast in these areas. So what will be the distance d that we wanted to find out in the beginning? So we can use Pythagoras theorem, like this base square plus the hypotenuse square is equal to the perpendicular square is equal to the hypotenuse square, right? So d square is equal to x2 minus x1 the base square plus y2 minus y1 square. So from here we get d equals root over x2 minus x1 squared plus y2 minus y1 squared. Okay, so this is the first thing that you need to remember. So there are like few points. We will build it up slowly. Okay, we will build it up from the scratch, the entire concept of straight lines. So this is the distance between 2 points x2 x1 y1 and y and x1 y1 and x2 y2. All right, and let's go with the next thing. Let's say this is x y, or same thing, coordinate, and let's say this point is x1 comma y1, this point is x2 comma y2, and here is another point which we need to find out. uh, this is m, and this point which is, let's say, a, maybe we can call it xy, whatever, m, and it is dividing this point p and q in the ratio m is to n. Okay, so this is pretty standard. Derivative is there, you can find it out. I'm not going to details, I will just write the expression here. What will be the coordinate x and y? So here x will be m times x2 plus n times x1 divided by m plus n, and similarly y here will be m times y2 plus n times y1 divided by m plus n. So I didn't go into too detail of how you will find this out, but I will give you a little bit of brief because you can work it out. You can see is that you can find out, as we already discussed here, you can find the distance between these two points and the distance between these 2 points, and the ratio between these two will be m divided by n. From there you can find x and y, right? So you can try this at home. I mean, it's not that difficult. Okay, now we will go to the some straight line properties. I will explain some of these concepts. Let's say this is a coordinate axis xy. Let me draw the entire coordinates axis here. So this is a straight line. Okay, so it's a little bit, so just consider this is a straight line. Okay, uh, and this is at a slope, at an angle with the positive x-axis theta. This line is making a positive angle theta with the positive x-axis, and let's say this point is x1 comma y1. One coordinate of the straight line is x1 comma y1, and let's say there is another coordinate which is x2 comma y2, right? So so let's say let us draw one parallel line with the x-axis here. So if this angle is theta, what will this angle be? Same thing, theta, right? Okay, so let's find the slope of this line. M equal to tan theta. This is called slope of the tan theta is called the slope of this line. Okay, and okay, so what will be the tan theta value? So let's say from here we want to find the tan theta value. So it will be y2. This is y2, right? And this one is y1. So what will be this distance I discussed before? This is simple, y2 minus y1, right? Similarly, this distance will be x2 minus x1. Okay, so from this triangle here, let's say I draw a triangle here. From this triangle here, what will be tan theta? Tan theta is perpendicular by base, right? So perpendicular, what is the distance of perpendicular? It is y2 minus y1. What is the distance of the base? It's x2 minus x1. And we know tan theta is called as slope, which is m. Okay, so from here we can find y2 minus y1 equal to m times x2 minus x1. Just for some people who might not understand what is slope, because I expect most people will know what is slope. I already explained that m is equal to tan theta, but let me just give a brief on what slope is, just for some people who are starting from the very scratch, so that we everybody is on the same page. Let's say this is an axis xy. Okay, so what will and we have a straight line here like this. Okay, and this straight line is cutting the y-axis at this point, and let's say this distance is c. So this c is called here the y-intercept. You can see from the English term intercept and y, you can understand at what point of y this straight line is cutting. That's why we call this c as y-intercept. And let's say this straight line is creating an angle theta with the positive x-axis. Okay, so in that case, what we call as slope here m, that is equal to the tangent of this angle theta we define that as the slope of this straight line. Let's say the straight line is L. So it's pretty simple. Let's say this is a straight line, it's called as L. It is ax plus the form, the let's say the general form of the straight line is ax plus by plus c equals 0. So here the what will be the slope, the tangent that this straight line is making with the x-axis, that is called as the slope of the straight line. And the intercept is at what point, first you need to find what point this straight line is cutting the y-axis. From there you need to find this distance from the origin, you will get the y-intercept. So these are very frequently used in straight lines, and these are like parameters, like what is the slope. So by the slope you will understand at what angle it is with the x-axis. So you will get some good idea when you know what the slope of a straight line is, about the orientation of the straight line. So I just wanted to discuss a little bit about that. So let's come back to this. So if we have 2 points x1 y1 x2 y2, then we find, if and we see that this is a straight line equation, y2 minus y1 equals m times x2 minus equation x2 minus x1. So this is called uh, okay. So this is called 2 point, just one second, 2 point coordinate system. I think it's 2 point coordinate. Okay, sorry, no, it's not called 2 point quad, it's called 2 point form. So I mean it's the same thing. Just wanted to see the exact name. Okay, so 2 point form. So this type of equation, when we have two coordinates of a straight line and we need to find out what is the straight line equation, we call this as 2 point form. So okay, let's move on. Let's say you have a scenario where it's pretty simple. Let's go like this. Let's see, you only have this straight line, the slope of the straight line as m, and you know it is intersecting the y at a y-intercept c. Okay, sorry. Okay, so this is c and this is, let's say it's angle at theta. So what will be the straight line equation? So let's find a common point, general point in this straight line, which is x comma y. So what will be the slope of this straight line? So we can go by the first principle as I discussed. What is slope? Let's say we don't know what is slope first, right? So let's say what is slope? Slope equal to tan theta. Okay, this is y, we already know, ordinate is y, and this is x. Okay, let's say this is a, right? So first let's find out tan theta from this short triangle. So tan theta equals what? C divided by a, right? Perpendicular divided by base. So from here we can find out what is a, c divided by m. Okay, and now let's go with the big triangle here, this triangle. So here this triangle again, m equals tan theta equals this y divided by this entire base, which is x plus a. So we already found that a is c by m, right, from this equation. So from here we can say y equal to m, when we multiply this m with this denominator, it's mx plus c. So this is called as slope intercept form. Why it's called as slope intercept? Because you see we only have slope and intercept as the unknown. no, as the known, right? So we have only two known parameters, slope and intercept, and from there we can form this straight line equation. So we call this as slope intercept form. Okay, now let's move on. So so right now we have discussed this two general form of this straight line. Everything is straight line, right? So let's say if we have just want to discuss one thing. Let's see if you have two coordinates x1, x2, y1, y2. Then you should use this form of the equation of the straight line to get the straight line. Let's say you only have, you know what the slope is and what the slope intercept is, then you should use this form to get the equation of the straight line, right? Let's move on. Now we will discuss. Okay, first let me draw the coordinate axis. So this is a coordinate axis x, y, and let's say we have a straight line with slope m, angle theta. Okay, and let's say this time we have only one point x1 comma y1. Okay, so what will be the equation of this straight line? Let's find out a general point x comma y. This is a general point, right? Any point you can consider x comma y. So what will be the slope of this straight line? So if this is theta, then this is also theta. We already discussed this before. So this part will be, this is y1, this is y. So this part will be y1 minus y, and this part will be what? This is x1 and this is x. So this is x1 minus x, right? Because this point is x1 y1, this point is xy. So this part is x1 minus x. So we will do the simple maths. What is the value of slope m? M equals tan theta, right? And what is tan theta? Perpendicular by base. So we get the perpendicular as y1 minus y and the base as x1 minus x. Okay, so we can, from here we can do y1 minus y equal to m times x1 minus x. Okay, so generally people like to write this as y minus y1 equal to m times x minus x1. If you multiply negative sign both sides, we get this equation. Okay, so this equation is called one point form. So what before we discussed, this is as 2 point form and this will be as 1 point form. So when we will use this equation, so we can answer this question from common sense, right? If we have 1 point, then we can use this equation to get the straight line equation of the straight line. Okay, so we have discussed what is 1 point form, we have discussed what is 2 point form, we have discussed slope intercept equation. Let's move on to another type of, another way to find the equation of a straight line. If we have a different scenario, let's say, it's a entirely different scenario, and then how can we define that straight line, the equation of the straight line? Let's say you have an xy axis again, and the scenario this time they gave you this, the straight line is like this, where here the abscissa is a, ordinate is 0, here abscissa is 0, ordinate is b. Okay, this is the origin. So what will be the equation of this straight line? So we know this is as a and this is b. Let's say, let's find out a point x comma y here. Okay, and So we can do it like from that this principle which we discussed before. I just thought about a minute about the way to derive it. Uh, you see this form which we discussed before, 2 point form where x1 y1 we know one for x1 y1 and the other coordinate we know x2 y2. The way we already defined it, right? This equation. We can simply use that equation to find this straight line equation. So what would be it? So it's like y minus, let's say this one, y minus y1 divided by y1 minus y2, which is this, b, x minus x1, which is a, x1 minus x2, which is 0. Right? We just use the previous equation which we already discussed, 2 point form. So from here we can, if we just rearrange this numbers, what we can get, y minus y equal to x minus x by a minus 1. So from here we can get x by a plus y by b equals 1. So this is called as slope intercept form. Sorry, just this is called as just intercept form. Okay. So why it is called as intercept form? Because you see we only know this intercept, we know both the intercept, we know x intercept, we know y intercept. I already told at what point this straight line will cut the y axis, that is called as y intercept. And now it is very clear that at what point the straight line will cut the x axis, that will called as x intercept. Okay, so we have discussed currently four type of straight line. It's like same type of straight lines, same straight lines, but if we have different parameters, then the which type of equation we need to use. If we have one coordinate, if we know one coordinate, we can directly use 1 point form. If we know both the intercepts, we can use intercept form. If we know, let's say, points, two coordinates, we can use 2 point form. And if we know the slope and the y intercept of a equation, we can use the slope and intercept form. Okay, so let's move on. And this is the last type, which is called as the normal form. So today is just the very basic class, basically all the type of equations. So I'm just even proving this. These are so basic, sometimes you just have to think, okay, what's the slope of this straight line is. So like that. So because I want to build it from the basics, and then we will move on to difficult topics, and we will solve problems, all kinds of problems. So okay, let's move on. So this is let's say this is an axis, xy axis, and we have this straight line. Okay, and now what are the parameters that we know this time? They told us that this the shortest distance from the origin to the straight line is p. Okay, shortest distance means this is at a perpendicular to the straight line, and it is making an angle alpha here. So if you know this too, that the shortest distance from the origin to the straight line is p and it is making an angle alpha, then what will be the equation of this straight line? Okay, so let's start doing this. So what will be, let's say this is a, and let's say this is b. So from this triangle, okay, what is cos alpha? Cos alpha is base by hypotenuse, right? So p by a. So from here you get A equals P by cos alpha. So you get here as P by cos alpha, right? And let's come to this triangle. So what will be this angle? If this is alpha, this is 90 degree minus alpha. Okay. So same thing, let's do cos 90 degree minus alpha. So brown base by hypotenuse. So here base is P by hypotenuse is B here. Okay. So what we get, cos 90 minus alpha is equals sine alpha, right? Equals P by B. So I hope you guys know this, right? The cos 90 minus alpha equal to sine alpha. We will cover this in triangles in trigonometry. So if you don't know, bear with me for some time, just because we have to go into details how cos 90 minus alpha equal to sine alpha. So you will find this in trigonometry. So from here, B equals P by sine alpha. Okay. So we already know what the slope, what the intercept form is, right? If you remember from the previous lecture, here we discussed what the intercept x by a plus y by b equals 1, where a is the x-intercept, b is the y-intercept. We will use the same form here. So here x by, what is the x-intercept here? P by cos alpha. So let's write p by cos alpha plus y. What is the y-intercept here? It is p by sine alpha. P by sine alpha equals 1. So let's solve this equation basically. So from here we get x cos alpha by p plus y sine alpha by p equals 1. From here we get x cos alpha plus y sine alpha equal to p. So this is called as normal form. This is normal form. So more, I basically discussed all the basics of straight line in this lecture. Let me summarize a bit so that it will help all of you, because next we will address some problems on this basic concepts. So whatever we discussed, let me summarize. What is the distance between 2 points where it's x1 y1 and x2 y2? Let's say 2 points, our coordinates are there. What is the distance between those 2 points? That will be x2 minus x1 squared plus y2 minus y1 squared. Okay, so this is the first topic that we discussed in this class. Let's say if you have a point, if you have like this x1 y1, if you have one coordinate x1 y1 and the other coordinate x2 y2, and there is a point a in between which is dividing these 2 points in the ratio m times n, then what will be the coordinate of a? Here x will be m times x2 plus n times x1 by m plus n, and y will be m times y2 plus n times y1 by m plus n. So these two we discussed in this class, and then we discussed some form of the straight lines, straight line equations. Let's say straight line equation forms, because it forms in under these categories basically. If you have these parameters, you don't have to think too much on what will be the equation of the straight lines, right? So here first we discussed, if you have 2 point form, 2 point form, so what will be the equation of a straight line when you have 2 points x1 y1 and x2 y2? I said it will be y minus y1 divided by y1 minus y2 equals x minus x1 divided by x1 minus x2. Then I discussed One did I think slope intercept, yeah, slope intercept form. So in this slope intercept form, what are the things that will be known to you? You will know the slope of the equation and you will know the y-intercept. Okay, so when you know the slope and the y-intercept, the equation of the straight line will be y equal to mx plus c. Now next, let's say you know one point form. You only know one coordinate. What will be the equation of the straight line at that time? But also, but you know one coordinate and you also know the slope. Sorry, if I by any case miss this point, let me clarify. In one point form, you will know the coordinate of one point x1 y1. Also, you will know the slope, right? That's how we derived. So in this case, the equation will be y minus y1 equals m times x minus x1. Let me go back and check once when I did it. Uh, so here you see, no, where is the one point form? Here you see, I automatically assumed I know the slope of this line. I hope I mentioned that while I was discussing it, but let me clarify anyway. So you will know the slope of this line and you will know another coordinate x1, y1. So in that case, you can use this form y minus y1 time equals m times x minus x1. All right. So next is intercept form. Intercept form, you know the x intercept and the y intercept. Let's say the x intercept is a, so you will get x divided by a, and the y intercept is b, you will get y divided by b equals 1. And let's say if you know the normal form, it's x cos alpha plus y sin alpha equals p. So in this case, you will know the shortest distance p from the origin, which is like at a perpendicular to the straight line, and that angle alpha, which that perpendicular line is creating with the x-axis. So more or less, this is what we discussed in this class. I hope you understood the basics. So one quick thing I will just cover it with the basics because because it should be in the basics only. Just one thing, just I will just fix this. Okay. So I will just cover it here. It's because it's not that it's very easy. That's why I don't want to take it to the next class. Let's say you have the same xy axis and you have this straight line like this. Okay, which is at a slope m1. Let's say you have another straight line like this, which is at a slope m2, but this is at perpendicular. Okay, sorry. So these two lines are perpendicular with each other basically. So what will be, so we know there is a very general relation between this m1 and m2. So let me discuss that. So let's say this first straight line, which has a slope m1, is at an angle of theta 1, and let's say this other straight line is at an angle of theta 2. Then what you can do is, let's say tan theta 1 times tan theta 2, which will be m1 times m2, right? So we need to find a relation between this m1 times m2. So what we will do is like, so let's say this is 90 degree and this is theta 2, this is theta 1. So this theta 2 will be 90 degree plus theta 1, right? Because an exterior angle is equal to the sum of the two opposite interior angles. So from here, what we can get is like, what is tan theta 2 then? Tan theta 2 equals tan of 90 degree plus theta 1, We just proved here theta 2 equal to 90 degree plus theta 1, and from here what we can get is it's like 90 degree plus theta 1. We will cover it in geometry, but I can give you a brief here. Let's say 90 degree is multiplied by 1, right? So if it is multiplied by an odd number like 1, 3, if this part, then we will first convert it into cot. And since it's like falling in the second quadrant, like this, let's say this is the first quadrant, second, third quadrant. So in this quadrant, tan will be negative. So that's why I just inserted this negative sign here. Okay. So from here we can write this is like 1 divided by tan theta 1, right? So this implies tan theta 2, which is m2, equals to minus 1 by m1. From here m1 times m2 equals minus 1. So this is also a very basic general form which we often use in respect in regards to straight lines. Okay, so yeah, remember this too. So I think that's all for this class. Then next class we will build upon it. I hope you guys enjoy. Thank you.